All right, so welcome to session 2, which is our invited keynote. This year's talk is going to be by Eli Ben-Sasson. We're very excited to have him with us. The title of the talk is From Stark to StarkWare, The Winding Path from Theory to Practice.
Thank you. I just want to make sure, am I supposed to start now or at on the 30? I think
we're starting now, and then we can leave some time for questions at the end. So we've got from now until the end of the hour.
Okay, terrific. So thank you very much for having me here. And I'm not going to use slides for my talk. It's going to basically be a little bit about telling my story and interactively doing so. So happy to answer questions about it. So this is going to be a story that I hope to touch on 4 themes that may be relevant to some of you either now or down the road. And feel free to ask questions and interrupt. So this is a question about the long and arduous road from theory to practice that is a little bit like walking in the desert that I want to share with you. It's also going to be a story about, second theme is the story of, about the stone which the builders rejected becoming the chief cornerstone, which is a verse from Psalms that sort of reflects a lot of what's happened, at least in my trajectory, but also to the whole field. I want to talk a little bit about managing, academic versus entrepreneurship, challenges there, and a little bit about the difference between research and practice, similarities and differences. So I'll just start. So a little bit just about myself, because I'm not a standard cryptographer in my upbringing. I was a theoretical computer scientist, and I did a lot of complexity theory. And then I started researching probabilistically checkable proofs. And from there, I slowly, the stuff I was doing slowly turned into having some applications to blockchains. And I'll tell you a little bit about that. And 3.5 years ago, something like 5 or 6 years ago, based on academic work that my colleagues and I did, I was a co-founder of Zcash, which is a cryptocurrency. By then was already long down the rabbit hole of cryptocurrencies in this fascinating world that I'll tell you about. And 3.5 years ago, I essentially left the academic life to become an entrepreneur. I co-founded another company that's around commercializing this latest piece of research that's called StarkWare. So I want to go back to the early days and say a little bit about this theme of the stone which the builders rejected becoming the chief cornerstone. So in the 90s and even late 80s of the previous century, the study of interactive proofs and then also the probabilistically checkable proof theorem emerged as a very important topic. You probably, a lot of you have heard about the PCP theorem. And within theoretical computer science, the PCP theorem has 2 possible applications. And one was always from the start immensely researched and became sort of the main thing about PCPs, whereas the other one was this stone which the builders rejected, collectively, but has become a cornerstone of a lot of things that happened since then. So one potential application of the PCP theorem is to prove inapproximability results. It is to show that assuming that P does not equal NP, then you cannot find an assignment. There's no algorithm that will find an assignment that satisfies more than 7/8 of the constraints of a 3CNF and many other celebrated results. You cannot approximate vertex cover better than some constant that's been improved over the time. So this was the branch that this study of the PCP theorem went through, and then like thousands of works have explored it. And once you put your focus on that thing, it's sort of, there are certain parameters that are very important. The number of queries that you make to a PCP assignment and the soundness that you get from it, those are really important. But things like the efficiency, the time it takes to generate a proof becomes second order, and it's not that interesting. And the time needed to verify it, not the number of queries, but the overall work that a verifier would need in order to verify a PCP statement or PCP proof, it takes second order. Okay, there was this early on, and the very first paper that led the way, showing the connection between probabilistically checkable proofs and inapproximability is a famous paper, FGLSS, Feige, Goldwasser, Lovas, and I think Sudan and Segedi. I may be forgetting the last two ones, but so this was a very important line of work. Now, there's the less traveled path that was taken and essentially started in two amazing papers by Babai et al. Was BFL and BFLS, and they explored what you can do in terms of scaling the verification of computation, sort of compressing the task of checking that a computation was done correctly, basically getting integrity on the cheek. And so two papers, one showed it first for all languages in NEXP. This was by BFL, but by Fortnow and Lund in 91. And a second paper that sort of downscaled it to NP with polylogarithmic verification of general computation by Babai, Fortnow, Levin, and Segedi. So these two papers that are highly regarded, but the sort of the path that naturally follows from them was very few looked at it. So because the main question in hardness of approximation is to get more problems for which you can get tighter results that you cannot approximate them well. So you get this line of negative results, these results of impossibility. Okay, but the line of works that looks into positive results about speeding up the verification of computation, there were very few works that looked into that. Okay, it was not something of interest. And if you look at that, then the things you're interested in is making the size of the PCP proof shorter, the time needed to generate is shorter, and you really care about the time required by the verifier to verify a computation. So all of these questions were not deeply explored. And so I'm going back to my own personal story. In 2001, when I started my postdoc, one of the questions that basically I started looking with, I was hosted at the time by Salil Vadan and Madhusudan at Harvard. So Salil Vadan was then at Harvard and still is, and Madhusudan was then at MIT and now is at Harvard. Question they basically asked me was about the length of the proof of a PCP, because there were a few works that looked at it, but not a lot. And I just came from different fields, so started looking into it, and we got some very nice results early on, but these results were all in the vein of getting the proofs to be shorter, and the way they were, so they got respect within the community of theoretical computer science, but they definitely always took second seat to anything that came out of the hardness of approximation line of results, because everyone was looking at that and knew. So there was the unique games conjecture and improvements on that, and it's beautiful and fascinating work. But sort of the question of getting the proofs to be shorter and more efficient was something that people said, okay, it's really cool that you guys are looking at it, but it's not really of interest. So I'm putting words in the mouth of the community, but this was sort of the reaction. This is not something that people really care about. But I and my colleagues, we found that a very interesting line of research and continued and proceeded there. So it was a bunch of. It started, I guess, my path into sort of the theory to practice started in looking at theoretical questions that I thought were very natural and led to interesting math, but were generally not found or not viewed to be of the most, the most interesting thing within the field that I was working on. in the larger field. The second thing that happened was that a bit later on, since the constructions we got were pretty efficient, even if you look at them semi-practically, the second thing that happened was that some graduate students and undergraduate students wanted, just out of interest, to do a project that involves theory to practice. So they wanted to implement some of these things. So early on, we had a construction, Madhu Sudan and I, about quasi-linear PCPs, where the proof length is nearly linear in the size of the computation. And it is a very FFT-like construction, so it's pretty practically efficient. So the first thing that happened was that already in 2005, Aradna Bhattacharya, who was then a student, now is a faculty member, an excellent one in complexity theory, but he needed to do a summer project at MIT, and he programmed one part of it, just implemented it. And then I was teaching courses at Technion and taught a course on PCPs, and students of mine came and said, we want a summer project like programming. So 3 students, programmed over the summer a full PCP system that is based on this. So it has a more efficient prover and verifier. And I still remember they did it for a SAT instance with 64 variables and roughly the same number of clauses. So a very simple statement so it was completely impractical, but they were like interested in programming it. And I guess then sometime later, I received this pretty hefty grant from the European Research Council so it was like 1.7 million euro that I didn't quite know what to do with, but I thought that maybe programming this kind of stuff, now that I have this funds, and there's no way I can pay theoreticians and mathematicians to really use it. So I thought that it might be a pretty good use of the funds. And I remember saying to myself that I have no practical application for this stuff. I really don't know why, but it's a good use for the funds, and I can now spend them. And even if nothing comes out of it, the worst thing that happened was that I funded, paid salaries for some students and programmers and things like that. And I can maybe, write a publication saying, look, this is what you can do with things like the PCP theorem. So thereby started my very long and arduous path through the desert of the theory to practice. It took something like 5 or 7 years. It wasn't a lonely journey. I had many colleagues that are still my friends and are still walking, walk this desert. First and foremost among them, I want to mention Alessandro Chiesa, who started as a master's student. Now he's a very, one of the leaders of this field, but he got into this. Madar Zvirza was also started as a master's student. Eran Tromer, Daniel Genkin, and then there were many others that joined along. So it wasn't a lonely journey, but it was a very long, and it was this sort of thing where we would write works that, from the practical point of view, made no practical sense because they were too inefficient. And from the theoretician's point of view, first of all, this was anyways in some area of research that no one is actually looking at, things like the efficiency of provers and verifiers, and measuring the concrete efficiency and the constants that you would get if you do this. So this is something that, the general field was not really something that people looked at, and writing more and more works about this was something that was sort of, it was, again, so it wasn't one person alone doing it, but it was a small group of people doing this alone with not a lot of reception, which was fine in hindsight. But I guess if there's any takeaway message here, I don't know, for those who are trying to do this kind of path. So, bear in mind that it's a very long process, and that most of the time you'll have this feeling that you see certain things and that these questions are really interesting. And I mean, both the questions and some of the answers you get to, but be prepared that when you try to present this to your colleagues, they'll sort of not quite understand why you're doing it, so this was a process that went on for a pretty large number of years. It was a lot of fun. It's not like we were we had any second thoughts about doing it. It was very clear to us that this is a meaningful use of our time and resources. But I mean, when you get yet another rejection of your paper on reasons that you clearly see that they're not getting it, or why this is interesting or important, where it really is, that's something that you're going to be experiencing. So the next turn of events happens. So we were chugging along, basically trying to implement the PCP theorem for practical reasons. And those practical reasons were to get better scalability, so that the verifying of a computation, of general universal computation, given by a generic program, could be done in much less computation than it would take to naively re-execute the computation. Okay, so this brings us to about the next. So this started. I started the project around 2009, and by 2013, I was there were some initial preliminary constructions. So I went around giving some talks about them, and then came this realization pretty quickly that it's not clear that they have any use in the world. And here there's sort of a miracle that happened, which is blockchains. So we had these set of constructions that give you essentially proofs, some of them with zero knowledge, some of them just that are much shorter than running the computation. And now you have them not just as a theory paper, but you have them in practice. So the question emerges, okay, what's the use case? I mean, someone's writing code for these things. So why other than writing a paper? And it's not, if you try to factor out blockchains, I mean, imagine a world where blockchains are not around. It's very hard to answer this question. Until this day, if you ask where in the conventional world outside of blockchains do you see real use, massive use of zero knowledge proofs, of proofs of succinct proofs of integrity, Starks, things like that, the answer is pretty much nowhere. And so I was giving these presentations that were geared at academics and other places, and I tried to find some examples. And I also had discussions with many people and sort of that had experience in the theory to practice. I remember talking to Ron Rivest and many others at MIT, where I was at the time, was doing a sabbatical. And they thought it's cool, but I remember Nikolai Zaidovich saying, yeah, sure, if I could press a button on Gmail that says everything that Google is doing with your information has been proved, sure, I would press that button, but like, why is it needed? And it's a very good question. Why in the conventional world would someone need to prove something to someone else? And the answer is, it's very hard to come up with good stories. I worked very hard to try and come up with stories, but they didn't quite catch on. And the reason, I'll get to it in a minute. What happened was, this was in 2013. So remember, this was already, I was down this path of theory to practice for somewhere between 5 years and 5 and 7 years, spending a lot of resources, my time, time of others, and there's no real use case in mind for this thing. And then there was this, so for me, it was this watershed eureka moment of, I went to, so I heard that there's a conference, a Bitcoin conference in San Jose, like the yearly Bitcoin conference. This was in 2013, so Bitcoin was turning like roughly 4. Bitcoin launched in, late in 2008 or just in the beginning of 2009. So Bitcoin was roughly 4 years old, and it was very young. And so I didn't hear much about it till then, but I reached out and said, look, I have this work that my colleagues and I are doing about proofs of computational integrity, that you can basically check things more efficiently and do it sometimes with zero knowledge. And they said, yeah, sure, well, that sounds interesting to us. Why don't you come and give a talk? So in May 2013, as I was doing my tour of giving talks in places like Princeton and Stanford, and having a lot of my colleagues sit there and said, wow, this is really cool, but like, why? Or what would you do with it? Or I went to San Jose, and this was by far the most electrifying conference I have been to till that day, and probably since then. The first reason was there was this sort of a Woodstock kind of aura to it. There was this feeling of the attendance that they are now evidencing and advancing a revolution in history, and they were very conscious of it. They are now changing the world for the better. So it was very electrifying to be in such a conference. It's still one of the most impressive events I attended. So that was one aspect of it. And remember, this was after having been many times in the standard Stock, Fox, TCC kind of conferences that are a bunch of very smart people, but there isn't this grand feeling of we are actually changing the world now. So that was one aspect of it. But the more important, on a personal level, aspect of it was that I gave this talk. It was called Universal and Affordable Computational Integrity. And rather than people coming like sort of glass-eyed and saying, wait a second, who's going to prove what to whom and why? And that many people showed up, and they were like core developers of Bitcoin at the time, Greg Maxwell and Mike Hearn, and a lot of these like, the founding fathers of that field. And essentially what they said is their questions were different. They were, okay, where's the code? Can we start using it tomorrow? And, no need to tell us applications. Here are like 4 different things that are really, really burning to us, and we would use this for them tomorrow. And I wasn't aware of it at the time, but later on, it sort of dawned at me that the world of blockchains, because of its assumptions, and maybe I'll show a few slides on it a bit later on what my realization is now. It wasn't clear to me then. It was just the sense that here is something. So it's not just me, it was this team of like 5 to 7 people that we were like walking this desert and doing things that we loved and cared about, but had no application. And suddenly you reach this oasis where the things that you're doing, people really are passionate about, and they see why they need it. Now, at the same time, we were also working on these non-PCP related or only tangentially related PCP constructions called SNARKs and quadratic arithmetic programs that are, again, by today, they're extremely popular. And at the same conference, also, there was a team from Johns Hopkins that presented a work about privacy, Zero Coin. And sort of shortly after, we realized that we've been building this really cool engine that we didn't quite find its use in the conventional world. Whereas they had this, they were academics, but were deeper into blockchains early on, and had this application of privacy and blockchains that they needed the right engine for. So we teamed together, and this led to Zero Cash, which was an academic paper that basically used ZK snarks in order to provide privacy blockchains and more fungibility, which then led to us being approached by a team of engineers that came from the sort of cyber security world, led by Zuko. And we partnered together. We were 7 co-authors of the academic paper on Zero Cash. We partner with the team of Zuko and his colleagues and founded Zcash. This was around 2014. So it was roughly like, or 2015. This was 1 year after this sort of eureka moment, or this watershed moment of realizing that this thing that we've been walking in the desert building and we loved, but no one really cared about, has this set of applications in this very weird and strange world that we didn't know about at the time. It was blockchains. So this got to about, so this is what led to Zcash, which uses ZK snarks, which is not quite the sort of PCP kind of stuff that we started off with. Maybe I'll pause here and ask if there are questions.
All right, and people can feel free to put questions in the chat, either here on Zoom, or I'm also monitoring on Zulip, or you can feel free to jump in. One sort of general question I have, like as a person who's also done this transition from theory to practice, after having gone through that, do you feel differently about the sort of like community conventions and support structures for people making that transition and for building that bridge between theory and practice? Or do you think there's things that we need to improve upon to make that more possible?
I think there's, and by the way, I see a question in the chat that I'll answer in a minute by Carla. I'm sure there can be a lot to be improved. For instance, I was already tenured when I started this path, and I remember saying to myself, "Okay, that's fine. Like I could survive, without publications that are cherished by my core community for a few years or forever. At the worst case, my next appointment would wait a bit." But I think for people early on in their career, for which this is extremely important, it's very hard to do these things. I guess the biggest, if I have to sort of pass criticism or what has to change, it is that at least the community that I was in was extremely, and maybe still is, extremely orthodox in saying, these are some questions that are really important. And when you, even before I started down this path, I remember sort of questioning this sort of, must it be this orthodox? Is it really that these other works that are, not exactly answering the 5 questions that I don't know exactly who even crafted, but that everyone's now rushing to solve? Must it be that they are, rejected from conferences and not cool and so on? And I don't have a good, so there is a lot of orthodoxy and a lot of saying, right, orthodox actually means right way. So there's the right way, there's a right set of questions that must be asked. And if you're not working on these questions that are decided upon somehow by the wise elders of the field, I'm guessing, then it's not so good. But I don't quite know what a meaningful change would be, because I think the history of society is such that there's always some, cabal of wise elders who now think that this set of questions is really important, and then some other cabal comes along and right, and sort of either appends them, or there's this saying, science advances one coffin at a time. So, the old guard moves away, and now there's a new set of questions, but I don't know how to actually make it. So like, it's not like that this set of questions is the right one. I don't know, just open-mindedness in general and more appreciation for a variety of questions would be good. I do think that the way conferences are run, sort of helps this perpetuate this thing, because conferences, instead of being sort of this thing that says, okay, you want to talk about something, she wants to listen to it, okay, let's just set this up. They sort of turned into this thing where only the most excellent works are selected to be presented, and sort of this mini ceremony prize, the prize being presenting a paper there. And sort of the statement is that, oh, the universities need this kind of thing so that they can decide who to give tenure to. And I don't buy that. I think it's part of this just general tendency to compete. So maybe relaxing that a little bit and saying that we're more open to all kinds of research directions would help. But yeah, having more open-mindedness would be a good thing. So the question that Carla asked in the chat is, do you have a theory of why this path was less explored, the path about succinct verification and efficient proofs? I think it has all to do with, I'm guessing it was before my time, but my guess is that it has all to do with personalities and people and sort of human politics, that certain people said this is really cool and they were the cool kids. So the others said, yeah, this is really cool, and that other branch is less cool. That's what I think, because I know I have no other explanation for. I think there are beautiful math and fundamental questions in this branch and beautiful math questions in that branch, and I don't know why one has been. So that's my conjecture, but I don't know. Okay, any other questions? So I'm not on Zulip, so I don't know if anyone's asking something there.
Yeah, it's been pretty quiet on Zulip today. Yeah, maybe people aren't logged in. Yeah, any other questions from the audience? Feel free to jump in.
Okay. Just okay, put it in the chat and we'll address it later. So I want to, my story has brought us up to the founding of Zcash, which was a terrific experience in sort of seeing your theoretical research, or even the practical research was not quite practical. It was an academic proof of concept. So seeing this process being carried out to completion, to something that actually people use, random people use on their desktops or laptops, and all the steps that were needed during that transition, fundraising, forming a company, hiring. I was viewing that from the side. It was a very exhilarating and fun process. I recommend all those who can to sort of be in such a position. It's a lot of fun. You learn a lot. You sort of broaden your horizons, or the set of skills that you're, all kinds of business negotiations, and seeing how the VCs and venture capital and fundraising and this, it's interesting. Just again, if you're very much an academic who likes to reside only in the ivory tower, as many of my colleagues are, that's fine. But it is something that's a lot of fun. You find out that there's a lot of very bright, interesting, smart people out there as well, not just inside the ivory tower. So that was fun watching it from the side. And another advantage of watching it from the sidelines was that I didn't quite have to manage this question of academic versus, being an academic versus being an entrepreneur, which did happen later on. So the research on, okay, Zcash is based on ZK snarks, which are based on number theoretic assumptions and knowledge of exponent. I'm sure that many of the viewers here know about it a lot more than I do, and have contributed much to this field. So you get constructions that are beautiful from a mathematical and cryptographic point of view. They have a main advantage of giving you extremely short proofs under 300 bytes and maybe under 200 bytes. But in terms of the amount of number theoretic assumptions and other assumptions, and the how new these assumptions are, they are quite, in my view, quite risky. And also, the mathematician in me sort of, I admire the ability to say, here's an assumption that, like knowledge of exponent and things beyond that is sort of, if you assume that, then the system is secure. But coming from the line of work of PCPs, the fact that you actually have to work really hard and prove something and prove that it's secure based on very minimal assumptions. The existence of any hash function, collision resistant hash function, which is the case with Starks and other PCP-based constructions, really is something that drew me in, and sort of I wanted to see that line of sort of PCP-based research reach its fruition. And here there was this theme that I think continues till today, both a little bit in the academic world and outside the academic world, which is that since pairing-based snarks were first, and they do a lot of things really good, it's once again extremely hard. So I sort of felt that I'm back in this desert again. So trying to peddle things that are things like Starks and things based on interactive oracle proofs, where there's a lot more math and a lot less number theoretic assumptions, is something that again, the community is not so much interested in hearing. And here it was a slightly different, or other sets of communities. So now this sort of, again, I had this experience of walking the desert, in the sense that on the one hand, by now the constructions were already extremely concrete and extremely practical. So by now we've completely left the world of PCPs as they would be appearing in, let's say, Stock and Fox and CCC. And there you can't even try to get anything accepted. But the world of, Usenix security, S&P, CCS, crypto, no admission there at all, because we already have, once again, I think it's a little bit of this orthodox here. We already have constructions that are really, really good. Everyone understands them. Everyone's working on them. Why are you bringing these things? So, and there I remember, so I once complained to Gil Segev about that, and he, it was, I think, after the third or fourth rejection of the Stark paper from some crypto conference, or just before it, and he quoted Monino, who told him, he was his PhD advisor, and he told Gil Segev that you're onto something only when your papers get rejected, where they're said to be not new, not correct, and not interesting. So I remember coming back to him a few weeks later, forwarding the next set of rejections, and said, I think I'm onto something pretty cool, because just look at this. Here's here are the rejections saying it's not interesting. They're saying that it's not new, and here they're saying that it's not correct. And it happened several times. So once again, sort of back to the desert, in a different kind of setting and community. But by then, we were already pretty convinced that this is a meaningful path to go down. So another kind of, I'm focusing only on sort of the hardships here, right? But another set of hardships came when I started to co-found the company. I was at the time a full professor at Technion. By now I left. In between, there was a lawsuit against myself, my wife, my father, my PhD student who was a co-founder. It was resolved since then, but sort of the challenge of dealing with academic institutions in the areas of computer science is another area that could, at least at my institution at the time, it could have benefited from a more enlightened approach, I would say, or at least something that sort of more embraces and allows academics to move forward with their entrepreneurship. So that's another area of sort of challenges and so on. I just want to ask, how much time do we have left?
So we have about 5 minutes for the scheduled session, but we could go slightly over.
Okay. So, yeah, I can go for like 3 more minutes, and then if there are questions. So 3.5 years ago, I decided to go and sort of leave the academic life and start StarkWare. And I talked a lot about the challenges, mostly again because so most of my talks usually are not about the challenges and the the things that are hard and so on. And I just want to say that in general, I think first of all, I really love this quote attributed to Winston Churchill that says that success is going from failure to failure without losing enthusiasm. So I think this is true even for people who are doing academic research, because we're faced with such, we're looking into these questions that are just so hard to solve. So you have to wake up day after day and experience failure and basically go on with your enthusiasm. And the person I learned this most from was my PhD advisor, Avi Vigdalson. I think he's well known to be among the smartest in math and computer science. But those who haven't worked with him don't know that as much as he is smart, he is even more optimistic, enthusiastic. So having experienced one failure after the other, he just comes charging again at it. So I'll just end with a few words on the differences between what I see in academics and entrepreneurship. So you see extremely smart people in both worlds, and extremely curious and resourceful. I think really the sort of difference is that, or the differences are that in scientific research, your aim is to go for the outer limits of what is possible and just show that maybe something can be done, and that's your focus. Whereas in business, the key to success is finding something like a minimal viable product. So it's the minimal use case of your technology that does something a little bit better than the rest, and you can already do something useful with it. So that's one big difference. Another big difference on a personal level is like loneliness versus team. So academics, especially ones doing theoretical computer science like I have, do it pretty much alone, day by day. And it's also very competitive on a personal level. So it's me against the rest of the world, or me and maybe my students and my 2 or 3 colleagues. Whereas in business, it's always this team, and this team grows larger and larger. I mean, by now StarkWare has 50 employees, and everything is, your focus and your pride is on the team. So that's another difference. Now, of course, a team comes with its, they're human beings. So now there are, things like egos and personal ambitions, and they show up a lot more. Academics are a little bit more like cats or bears, right? You can all go and, be territorial in your own area, and you meet once in a while in a conference and then go and part ways. Another one is the difference between the ability to plan ahead and sort of just go after your heart. So with research, you're basically going from one thing to the next. And in a team, so I still remember that one of the very first meetings when StarkWare was founded, we sat with our VP of engineering, who's a very good friend of mine for several decades. And he said, and at the time, most of the knowledge of the technical knowledge resided only with me and my other co-founders. And they looked at us and said, okay, so please put a plan for the next 3 months of, what are the first 5 people going to do? And I was amazed, like, what do you mean? People actually can solve this problem of planning for 5 people's what to do in the next 3 months. So the sort of the need to plan and orchestrate large groups is something that you see very much in the in the practical world, but don't have it in academics. And the last thing, which is similar, that you need the optimism, brilliance, grit, and seeing things through is really, really important in both of them. So I see, like, sort of, I went to a different world, but I feel that I'm still very much left in, residing within the same universe as before.
So it looks like we have a question in the chat from Kevin.
Yeah.
before we wrap up here. So he says his perception is that cryptocurrencies still have a ways to go in practicality because of very few of the world's transactions are conducted this way. What is the barrier to adoption of them as a currency by the population at large?
Yeah, so that's a really terrific question, because actually I think so. There are several things that need to happen. I mean, some regulatory things and so on, but that's not so much of interest. The biggest thing that is impending them right now is scale. And I haven't, this was a talk mostly about just, personal travails and failures, because that's the nature of this conference. But what the technology that StarkWare is doing, and that I co-invented, and all my research is about using proofs of computational integrity in order to exponentially scale the amount of transactions on blockchains. And I'll end with words of success. So by now we processed over 1 million transactions on the blockchain. We've settled more than, I think, $2 or $3 billion worth of transactions. We're seeing sort of this hockey stick rise in the number of transactions that are residing on our technology, which does allow to scale. We can reach a transaction per second rate that is 3 to 4 orders of magnitude higher than what blockchains natively can do, and all of that without breaking any of the security assumptions of blockchains, which is a different talk that I'll give some other time. So the stuff I wanted to talk about, failures and keeping on and moving from academics to entrepreneurship, I'm done.
And I think we have another question from Carla, and a vote from Stuart to continue. So we will take that to heart.
So you said at the beginning that it's very hard to find use cases beyond blockchains. But do you think this will change when as it really becomes very efficient? Because personally, the way I view all of these proofs is like solving a very fundamental cryptographic problem, which is how you get usability when you have confidentiality, right? So yes. I see this as going beyond, like maybe not short term or something.
Yeah, I completely agree with you, but I think the main hurdle is not so much like efficiency. It is actually sort of the basic premise of the conventional world. So the way the world solves these problems of confidentiality and so on is to say, we will take a trusted party, we will entrust it with all the information, and it will run this computation on behalf of everyone, and will do so efficiently, and will trust it. And this has been going on for millennia. And it works very well. It's extremely efficient. And in most cases, if that party is indeed, honest, which often it is, this works very well. So that's the main hurdle that you need, because any sort of proof or secure multi-party computation is going to be much less efficient in terms of the, CPU time. So either you're going to see that governments are going to demand that, and the public is going to demand that, or that blockchain sort of become the thing, that's sort of decentralized world becomes so prevalent that everyone needs it. But I don't think any bank anytime soon is going to say, oh, we're going to prove stuff to our users, we're going to entrust them with their stuff and they're going to prove it to us. I don't see that happening. That's going to be a major disruption that's going to come as a disruption.
And we have another question from Felix in the chat. Who says, as I see it, blockchain startups found a decent way to bridge the theory practice gap of zero knowledge proofs. Do you know of another business field where other areas of cryptography could be bridged to practice?
That's a terrific question. I would say, but again, I'm okay. I think zero knowledge is basically just the basic layer of, it's like one-sided MPC where Alice has all of the secrets that in the secure multi-party computation. So definitely, I think the next thing that hasn't really started that much yet would be MPC for things like auctions and these settings that dark pools and things like that. Everyone's talking about FHE, which of course sort of complements and is very strong, and then you have indistinguishability obfuscation. Those probably would come later on. I don't know. I mean, it's a terrific question. I'm not the right person to ask. Another area that I think is gaining a lot of popularity is differential privacy, and related to it, but there I think there's still research needed to be done, which is this whole notion of algorithmic fairness, which is a very important topic in society. It's not clear exactly what areas of crypto touch on that, but so I would say MPC, next thing, FHE, I don't know, maybe everyone's talking about it, but seems a bit harder, and then differential privacy. And but I would say that I anticipated in those cases as well, it's not going to be just pure standard. There's a very non-trivial task that we also had to do with proofs of finding where is the right place to put the technology. It's not the I mean, a lot of talks start with, oh, delegation of computation, right? There's a cloud, you don't trust it, so on. It doesn't practically, it doesn't work that way. No one doesn't, no one cares about, no one needs to verify Amazon's work using a proof, practically speaking. So you need, there as well, I think you're going to need to find a creative way to insert those technologies, differential privacy, FHE, and so on.
Just a note for those of you outside the U.S., differential privacy is involved in the U.S. census data this time around, and there is a huge lawsuit going on where states are actually suing the U.S. Census Bureau about the use of adding randomness, claiming that it's making the stats inaccurate. So that's a very interesting, and it's been great to sort of see theoreticians get involved in writing briefs and arguments about that. So there's some great pieces written by cryptographers involved in differential privacy, explaining this to the general sort of like consumer audience. So I would encourage people to check that out if you haven't seen it. So thank you so much for joining us and being willing to share some of your journey and your failures and your hopefully many more successes to come. If everyone, just for scheduling purposes, we'll be back here at 2 p.m. In the meantime, there is a women researchers panel going on, so it just started, so feel free to head over to that, and let's thank our speaker one more time. Thank you so much.
Thank you. Thank you for having me.